Good afternoon and welcome to Valve Accessories. We've been doing these videos for a couple of weeks now, and we're going to continue today with our V100 product. My name is Carly and I'm the marketing specialist here at VAC, and this is Scott. And all of our videos are on our YouTube channel. You can go back and watch those, or if you have any questions, don't hesitate to give us a call. Our website and our phone number information are all linked in the bottom of this video in the description. So if you have any questions, don't hesitate to give us a call and we'd be glad to help you out. Make sure you follow us on LinkedIn, Facebook, and then our website will update you there with video links and any technical tips there. So give us a call if you need anything else. And I'm going to hand it over to Scott.
Like Carly said, today we're going to be going over the V100 mounting calibration, feedback on the V100, and a couple of the different options we have. We're going to wait just a minute or two and let a couple more people see if we can get some more people signed on and what exactly is happening. And once we give it just a few more seconds, we're going to go ahead and get started up here. All right, giving everybody a little chance here to get online, and we're going to go ahead and start everything up. What we've got here today we're going to talk about is we've got a V100E. We've got the electro-pneumatic unit, which means we have the internal I to P. So we're going to give this unit a 4 to 20 signal to operate 0 to 100% or 0 to 90 degrees. We're using a rack and pinion double acting actuator today. The first thing we generally talk about is when we go to mount a positioner, we're going to take this thing out of the box. And with a V100, the spindle is generally installed inside the unit. Oftentimes, somebody may repackage it and it may not be installed. But if it is, or it is not installed, what we're going to do is we're going to take our spindle. Notice we have the male end and we have a female hole here. And what we're going to do is we're going to click this in. You hear one click, 2 clicks. The second click means we're engaged. And as we turn the spindle, we're getting turning inside the unit. Once we get our spindle installed, the next thing we're going to do is we're going to go ahead and install our positioner onto the bracket. Questions we've had a couple times in recent days is somebody wants to reorient this positioner. Currently, the way I'm going to install it will be to the gauges and the porting to the left. If you want to install this positioner, you can install it in any position you would like, all the way around. But the thing to know is once the positioner's been installed and calibrated, you'll have to make sure you loosen the set screw and the cam nut. Now you can orient this in any direction you want, and you'll be able to tube it up. But the critical thing is making sure you loosen that cam so you don't jump the setting. So I'm going to go ahead and install it in this direction. I'm going to put a couple bolts in. Put a few bolts in and hold this guy in place. If you notice on the positioner on an electro-pneumatic unit, you'll have a plug in the I port on the side. Then you'll have 3 open ports. You'll have a supply, a C plus, and a C minus. Or S, a C plus and a C minus. The S is for supply, and I'm going to connect my supply. Connecting my supply to the middle of the 3 ports. The other 2 ports, we have a C plus and a C minus. The C plus is for when you increase signal going to your I to P, so you're going from 4 to 20 milliamps. As you go towards 20 milliamps, output is going to increase on the C plus. This is a double acting unit, so we're going to tube to the C plus and C minus. If this were a single acting actuator, you can tube to either the C plus or C minus, depending on the configuration you need, and plug the other port. You would just put a solid plug in the port. in this configuration, we're going to have the C minus to the driving closed and C plus to the driving open, because we're going to set this unit up to where it is 4 milliamps closed, 20 milliamps open. Currently, the actuator is in the full closed position. Once the positioner is tubed, and the next step is going to be to set your cam. One thing we want to do when I set our cam, like I said, we want to make sure that our set screw is loose, which is just a screwdriver, and then by hand you should be able to loosen the cam nut. What we're going to want to do is rotate the cam slightly out of this trough, away from the tip here, and we're going to lock it down, the cam nut down with one hand. Once it's locked down, you can release it and it won't move. You'll be able to fit a screwdriver slot in this groove next to the roller bearing slightly. Now we're going to tighten down our set screw, and our positioner is mounted, our cam is set, and now we'll put air on the unit. Once we put air on the unit, one way to ensure that our tubing is correct is to reach up above where the pilot valve inside the unit. The stem sticking out of the pilot valve goes over a stainless steel tab we call the balance arm. If we press down on that arm and we see we can use a screwdriver or a hand, but if we use a screwdriver and press down slightly, we'll see that the valve moves towards the counterclockwise or open position, so we know tubed we're correct. Once we have this configured and we know we're tubed properly, our cam set properly, we can start to calibrate the unit. What I'm doing, connect my Mr. Signal. With the V100, we have two different places that we'll have to adjust for calibration. For one place in the bottom of the unit, there is a plug. You remove the rubber plug, and there's a slot for a screwdriver. That is your zero adjustment. Inside the unit, there's a red wheel. This will be our span. At a 4 milliamp input, we're going to adjust our zero. And what we will do is we'll adjust our zero until we see the C plus gauge rise off of zero. So we're watching our C plus gauge and we see it rise off of zero here. And then we'll turn the opposite direction until we get that C plus gauge to zero. Now that we've calibrated our zero, we're going to go to full span, go to 20 milliamps. And now what we're going to do is we're going to adjust our our span wheel, which is the red wheel, until we see the C minus gauge go to zero. I've adjusted the span until our C minus gauge has dropped to zero in about 3 to 5 seconds. If you go to our website, there's a good single-page instructions on how to calibrate the V100 to gauges. We use that quite often. The reason we use that calibration to gauges sheet is so that anybody can calibrate it and calibrate it the same, that there's no translation or feel or one guy does it differently than the other. If everybody does it to the gauges per that sheet, every calibration is going to be the same. And we're at 20 milliamps now, fully open. We're going to go back to 4 milliamps and double check our zero. And our zero is good. Span is good. This unit is now calibrated. The unit was calibrated as an electro-pneumatic unit. The calibration procedure is the same for a pneumatic. To convert this unit to a pneumatic, we would just pull the I2P. We'd put a new pneumatic plate on top. We would remove the plug in the I port, and we would give it a 3 to 15 PSI signal from a regulator or from a remote mounted I2P, and we would calibrate it the same way. 3 PSI would be our zero calibration. 15 PSI would be our span calibration. You'll see, like we've talked about on this gauge, on this unit, we have gauges. The top gauge is our I port gauge. This gauge is very helpful in telling us basically the health of the I2P itself. Like I said, if we have 4 milliamps going to this I to P, we should see about 3 psi on this gauge. And if we have 20 milliamps going to the I to P, we should see about 15 psi on this gauge. So this gauge, the I port gauge specifically, helps us determine that the I to P is functioning properly. The V100, we do have feedback available on the V100. This is what we call our R100 unit, and it is a stackable unit. The V100, normally, you'd have your arrow, and you would place your cover, and you would be done. If feedback is needed, we'll remove the arrow and the cover, and we have the R100 available, and it is a stackable unit. You do have to have the positioner itself mounted and calibrated before you install feedback, the R100 on top. The bottom side of the R100, you'll see, has a shaft with a slot in it. You want to make sure that slot lines up with the slot in the top of the positioner. Once you hear that click in, there's 3 screws that you'll tighten down. The R100 that I have installed has both 4 to 20 feedback and mechanical switches. The mechanical switches are adjustable with cams. The lower cam you'll pull up and turn to set the proper position, and you'll push down. The top cam you'll pull up and turn to get set in the proper position. For the calibration of the 4 to 20 feedback, I'm going to go ahead and hook up to it. Inside of the positioner, you'll see that we have a potentiometer and a gear wheel for our calibration. I have my leads plugged in properly into my Mr. Signal. We'll notice that currently we have 3.913. If that was needed to be adjusted, our course adjustment is available or is accessed by pulling the potentiometer out of the way and turning the small gear wheel, reaching in and turning the small gear wheel until this reads close to 4 milliamps. Once we get close to 4 milliamps on that reading, currently we're at 3.917, we can come in and we can adjust our 0 fine-tune pot till we are right at 4 milliamps. A little bit overshoot. Once we get it set at 4 milliamp output, what we're going to do is we're going to go to 20 milliamps on our signal. Once we get to 20, we're going to look where our feedback is. We'll go in and we'll adjust our span trim. Till we get to 20 milliamp output. All right. Was told that we had a little issue with our aim on our camera. So I'm adjusting now to where you can actually see the second line on our feedback. We're going to adjust that to there. Now we've got our feedback adjusted. Now we have 20 milliamps in, 20 milliamps out. We're going to go back to 4 milliamps and double check. Looks like we'll have to adjust it ever so slightly. Adjust it until we get to 4 milliamps. And now we've calibrated our feedback, mounted and calibrated our feedback. Like I said, this is a 4 to 20 with mechanical switches. The R100 also has proximity style switches available as well, or reed switches available. And now if we were done with the unit, we would mount our arrow, and the cover for the positioner now mounts in its place. Other options we have available is if you want to mount a dome indicator, we have a dome indicator available that is as simple as popping out the cover, popping in the indicator. The dome will go in the place of the arrow, and now the dome indicator goes on. This particular unit, like I said originally, this is a V100E. If it is available in an EX, the way we do the EX is even though it is a pneumatic device with an EX, we would convert it to a P. We'd pull the standard I to P out, and the EX I to P would mount side saddle kind of to the side, just like on the V200 version. Other options we do have available, or we'll pull it down to where we see the positioner itself. We'll remove this so you can see in the positioner. Inside the unit, this is a standard 3 to 15 spring. We do have a second spring available that is a 6 to 30. These are generally only used, they're only available in pneumatic configurations. When you go to the 6 to 30 spring, as the I to P is only capable of putting 3 to 15 PSI out. But on some older systems with pneumatics controllers, it does take a 6 to 30 spring. So that is an option. And it's a pretty simple change that you'll just pull the spring out, pop the new spring in its place, making sure that these two grooves line up with the grooves in the back of the glide arm, and the unit's now been converted to 6 to 30. On a V100, it's pretty simple. Two major components. If you need for repairs or to keep on your shelf, just like on the V200, we have a pilot valve and an I to P. Two main components that end up seeing issues with dirty air. Oftentimes the pilot valve itself can be repaired. A properly functioning pilot, if you turn it just barely off of horizontal, the stem should try to slide out, so you know it's functioning properly. If it doesn't do that, one thing you can do is pull the pilot out, clean it using a non-residue type cleaner, denatured alcohol, or we use CRC contact cleaner here. You can use a pipe cleaner to clean it out, and actually to clean the spool valve itself. You'll take the spool valve out, just pinch it between two pieces of white paper, or take a piece of white copier paper and pinch it around it and just spin it, and it will polish these journals and clean it up ready for use. So oftentimes the pilot valve will not have to be replaced. It just would need to be cleaned. Like I said, the second component is the I to P, and it is simple as taking one screw out. Let me turn the power off. We'll convert this to a P just to see. We will loosen the one screw, remove the circuit board, and gives you access to the terminals for your wiring. Then two screws on the top of the unit. Remove the I to P. Replace the I to P with a pneumatic plate. Now it's been converted to pneumatic.
Scott, you mentioned earlier on the EX I to P. Can the feedback and the positioner both be explosion proof?
Yes. If you are converting this unit to an explosion proof, our R100 stackable unit is general purpose only. If it is required that you need feedback at that point, if you have converted this to an EX, like I said, the pneumatic plate will come off, the I to P will go in its place. Now this unit is EX. Because the electronics are in an explosion proof enclosure, If that is necessary, we offer a third-party mounting kit. And it's what I have here in my hand. What it is a mounting kit that replaces the cover, our standard cover, and allows us to bolt an explosion-proof housing onto this cover. A little adapter goes on top of the the shaft here, and this mount will mount in place of the cover. The requirement is on this particular mounting kit is that it has the 2 1/4 inch bolt square, so similar to Westlock and many other manufacturers have. We also have a Stonell kit available and a couple others that we may be able to offer. But if you need switches in an explosion-proof positioner, you do have to go to a third party, as our R100 is general purpose only.
Can you go over some split range stuff?
Okay. I'll convert this unit back to a electro-pneumatic real quick. Split ranging is generally something we see a lot in older systems, or systems where what you're doing is you're using one signal to control multiple valves. Convert this back so we can show it operating. Several different options we do have on our webpage. A cam sheet, and the cam sheet goes through each cam setup that we have available, and it shows what that cam is capable of. The standard C1 cam that I'm using now is, if I'll remove it so we can see it, show it a little better. What I've done is loosen the cam, loosen the set screw. I'm removing the cam nut. I'll pry up on the glide arm just a little bit. We'll pull our cam out. I'm not sure if we'll be able to see on the screen here. It's going to be tough to see. But what we have here is a C1 cam. It's A side. We have a 90-degree. We have a. Well, it's going to be hard to see. But the cam, the standard C1 cam is 0 to 90-degree linear, and on the other side is 180-degree linear. What you can do with split ranging is, we were using the C1A side on the 90-degree side of the lobe. If we pull this cam up, flip over to the 180-degree side of the lobe, what we can do at this point is, this cam is set up for 180 degrees of rotation. This is only a 90-degree actuator. So with 180 degrees expected for full signal, that means we can divide that 180-degree rotation into 2 90-degree rotations with half of the signal. So the first half of the signal, so 4 to 12 psi will turn 4 to 12 milliamps will turn the valve 90 degrees. From 12 to 20, you would be able to control the second valve, and I'll show you how we'll set it up. We'll set this up as the first valve for the first part of the control signal. So what I've got set up is currently, we have it on the 180-degree C1 B side of the cam. And what that is going to allow us is, even though it is a 90-degree, only 90 degrees of rotation on this actuator, now we have 4 milliamp input. We're going to go to 12 milliamp. And the valve went to 90 degrees to fully open. I'll change that back and put the arrow on it so you can see it. So we're at 4 milliamps. The valve would be fully closed. We go to 12 milliamps. Now the valve is going fully open. The new 12 milliamp position would be adjusting your span, which would be the red wheel. The 4 milliamp is 0 as normal. That's your first control valve on a split range. If you're going to split range a second control valve, we'll have to set our cam up slightly differently. We're going to go back to the 4 milliamp position. Make sure the valve is in the position you want it to start in. We're going to start at 0, fully closed. We're going to loosen the cam again. Trying to bleed off the air here. There we go. All right, so we're going to loosen our cam. To start the second control valve, on the C1 B side, there's 180 degree, there's a second mark. That second mark will be essentially where it stopped turning 90 degrees earlier. So that becomes our new 0. So we'll have to set our roller bearing up right on that mark. And what that becomes, lock that down. Roll the camera around, lock it down. Now, at 4 milliamps, we've got no movement. We're going to go to 12 milliamps. We have very little movement, so now what we would do is we would calibrate our 0 at 12 milliamps until we see our C plus go to 0, which we have now. So our new 0 for the second control valve is at 12 milliamps, but we're calibrating our 0. So at 12 milliamps, we'll adjust our 0 till we see 0 pressure on C plus. Now we'll go to 20 milliamps, and you'll see that the valve is stroked fully open, and we'll calibrate 20 milliamps as our span on the red wheel. Should just take a little bit. So now that we've calibrated it, we can put the arrow on so you can see. So at 20 milliamps, we're fully open. 12 milliamps, we're fully closed. 4 milliamps, we see no change because we're already fully closed. If there were 2 valves hooked up, when we went from 12 to 4, you'd see the other valve go to fully closed. So that is how to split range. So 90-degree split range on 2 splits, 2 90-degree valves can be done with a standard C1 cam. There's a bunch of other configurations. Every cam has different ways you can configure it. There's a couple of ways to look at that, but like I said, there's a cam sheet on the website that you can go into and shows you the different configurations you can use each cam for. All right, so everybody, that's going to be the end of this one today. If you got any questions, just give us a call, hit us up on the chat, give us emails, go to the website. Our contact information is on the website. I'm going to hand it over to Carly, and we will see you guys on the next one.
Okay, I'm just going to give you just a couple more seconds. If you have any other questions, feel free to drop them in the chat, and we'll be glad to help you. Okay, and I'm going to ask you guys just a couple of questions, and we're doing some giveaways this week. So if you know the answer, drop the answer in the chat box. And the first question is, what is the first step when changing the orientation of the V100? What do you do first when you're changing the orientation?
All right, everybody. If we need to change the mounting orientation of the positioner, what should we do? What is the first thing we need to do so that we're able to change it without messing anything up? Marv, MD is correct. We need to loosen the cam. That way we don't change the setup and we were able to set the cam properly. If you have the cam set and you just loosen the bolts and crank it to the other position, what it's going to do is it's going to change where the roller bearing is in the initial setup of the positioner, and it is going to give you fits when you go to try to operate it unless you reset the cam. So you are correct. Mark, if you can, please be sure we have your name and email so we can send something to you.
Okay, question number 2. Is the calibration procedures the same for the V100P and the V100E?
Marie, yes, it is. The calibration is the same. The only difference being where you get your signal.
Okay, thank you, Marie. And number 3, do you calibrate the V100 before or after you install your feedback?
Marie, please let us make sure we have your email as well. Johnny Carroll Sr. is correct. Yes, you have to make sure that your positioner is calibrated, your cam is set properly, and that your positioner is calibrated before you install your feedback, or you will have to remove your feedback to set the cam and calibrate the position. So you guys are correct. Several of you are correct. Looks like we got pretty much all correct answers today on all the questions. So everybody's doing great. So Johnny, please, Johnny and Marie, please make sure we have your contact information so we can get something out to you guys.
Okay. Thank you guys for logging on today. Next week, we're going to be here same time, 1:30 next Tuesday. So be on the lookout for the link for that. You can stay updated on our LinkedIn and our Facebook pages. If you have any other questions, let us know. Give us a call or shoot us an email, and we'd be glad to help you. Next week, we are going to go over retrofitting, so join us then. Thank you, guys.